Okay. In yesterday's class, we had finished independence. So we have seen what is conditional probability. Conditional probability. And then what is independence? And then independence. So we had seen yesterday how do we prove that two events are independent. So if you want to prove that A is independent, A and B are independent, A and B are independent, then we need to prove, you should remember that, then we need to prove that probability A given B equals to probability A given B complement equals to probability of A. And the second thing, probability B given A is equals to probability B given A complement is equals to probability of, then we say that A and B are independent. Just a minute. मैं चार्जर तो ना लैपटॉप का उधर सामने कॉल करो पहुंचेगा नहीं okay so we have seen this was the condition by the way. Okay, so now we'll see that what effect does independence has on intersection means I'll show you what it happens if A and B are independent, then what you will note on the intersection independent, then probability of A intersection B probability of A intersection B can be found as probability of A, this intersection, I've told you this or when we were studying or, I've told you that or means, I'm writing in this in box because just bringing the previous concept. This or means probability of A or B means probability of A plus probability of B. How was we have taken or and union as plus? Yes or no? Likewise, if there is a condition here now, if they are independent, if they A and B are independent, then we can make the intersection sign as multiplication. Means we can write it as probability of A into probability of B. Right. Yeah. So that's when what's the condition, but they must be A and B must be independent. Then I'll write once again. If A and B are independent, then probability A intersection B equals to probability of A into probability of B. That is. Now we'll see the explanation how he has given it in the textbook. Okay.
Mm-hmm.
We have seen this. Had we done this example? Yes or no?
Mm-hmm.
Okay, come on, we'll do this. What it is there a relationship between gender and handedness? We had to find a relationship. We had to state that is there a relationship between gender and handedness? Okay. So gender, what I'll do, I had to find a relationship. Very important question this is. So what will be A? It will be male. Okay. So A complement will be female. I'm just noting it down because you should remember. Then what it is, dominant hand. B is right dominant hand. Right dominant hand. So B complement will be left dominant hand. Okay, that is the thing. Okay. Now what we have to find, are A and B independent? Are question is, are A and B independent? So now what we need to verify again, probability of, find probability A given B. So what will be probability A given B? Given B means B has been fulfilled. Right-handed, right dominant hand. Right dominant hand, it's 90, so it come in the denominator, and the intersection of A and B means it is right and it's female, it is 39. Okay. Then we need to find probability of A given B complement. So what is B complement? It is left. Yes, so left is total is 10. So it is 10 upon A intersection B complement. So left and male. So it's 7, 7 by 10. So it will be around this. If you calculate here, so it is likewise 39. It's 43%. Okay, 43%. This will be 43% and it is around 70%. Yes or no? That's the case. So
Mm-hmm.
you can see both of them. Probability of A given B is not equal to probability of A given B complement, and it will not be equal to. So you need to find probability of A. So what is probability of A? Probability of A means probability of male. So A is male, na? So male is total male. It's 46. So it will be 46 upon 100. So it will be 46 upon 100. So it will be around 46%. So this is also not equal to any of the others. So now, so therefore, what you will tell that A is dependent on B. A is dependent on B. The same you have to prove it the other way. Yes or no? So you will do it the way.
Mm-hmm.
Then so there is a relationship between. So what you will say, there is a relationship, because when there is dependency, I've told you, when there is dependency means there is asking for correlation. Means, for example, if A increases, then B also increases, or if B increases, A decreases. So this is relationship. No? This is positive and this is negative. So whether it is positive or negative, he was not asking. Just he is telling that is there a relationship? So if there is dependency between the two variables, between X and Y, then we can say that they are dependable. Therefore, they are dependent. Therefore, they have a relationship between them. Suppose we choose one of the students in the sample at random. Are the events male and left-handed independent? So we have proved here. Male and left-handed are not independent. They are dependent. Is it clear by the answers?
Mm-hmm.
Yeah.
Yeah, I got it.
Yeah. So we go on to the next question. So he has shown how to do that and explain also. So now you can do this example as well. Not a big task. Okay. So we'll move further. Shall we do here in class?
Mm-hmm.
Okay, we'll see it afterwards. Okay,
Yeah.
the
Okay.
general rule of multiplication. See, what was the general multiplication rule? We had learned the general addition rule, yes or no? Or you can say
Mm-hmm.
the general union rule. But what is the general addition rule? Multiplication rule. So he is explaining to you. See here, he has here given the general addition rule. Yes or no? So now what we will
Mm-hmm.
learn is the general multiplication rule. So the general multiplication rule is probability of A intersection B is given by for any random process the probability that the event A and B both occur can be found using the general multiplication rule. So he has given a more intense form of it. It is given the general form by the way. I had given the
Mm-hmm.
specific form. Yeah. So what is the general A and B? So and is also known as intersection. So it is A intersection B. So it is given by probability of A into probability of B given A. B given
Mm-hmm.
A.
Yeah.
That's the principle. Okay. And you know if A and B
Mm-hmm.
are independent, if A and how does it changes to specific? If A and B are independent, then you know that probability of B given A, what it is equals to probability of B, yes or no? So
Mm-hmm.
in place of this, we can write this, yes or no? So what it will happen? Probability of A intersection B. This one is general. This one is general.
Mm-hmm.
Okay, and this one which
Yeah.
I'm writing is specific. Specific means if A and B are independent, then we can do. If they are not, we have to use this formula. If they are independent, then we can use this formula that probability of A into probability of B. Understood?
Yeah.
Yes or no? I don't
Mm-hmm.
need to give an
Yeah. I got
example
it.
or something of it. So, or else we look into this one. Okay, so we'll read this. Suppose that A and B are two events resulting from the same random process. We can find the probabilities, probability A or B, okay, with the general addition rule. Addition rule. How do we find the probability that both the events happen? Probability A and B. Consider the situation about 55% of the high school students participate in a school athletic team at some level. Roughly 6% of these athletes go on to play on a college team in NCAA. What percent of high school students play a sport in high school and go to the play on an NCAA team? About 6%, 55%, or roughly 3.3%. Let's restate the situation in probability language. Suppose we select a high school student at random. What's the probability that the student plays a sport in a high school and goes to play on an NCAA team? The given information suggests high sport is 0.55. Yes or
Mm-hmm.
no? High school sport is 0.55, 55%. NCAA team, it is 0. It will be NCAA team, na? So it was given to be 6%. So it will be 0.06. So by the logic, we have to find an intersection. Students who go in both of them, high school sport also and NCAA team also. What I need to find?
Mm-hmm.
Probability of high school into probability that he goes into high school game and then he comes into NCAA team. Yes or no?
Mm-hmm. Yeah.
Okay, so it will be 0.55 into 0.66, correct? So it is
Mm-hmm.
0.033. So it is around 3.3%. This is an example of general multiplication rule. This is, he has given the general multiplication rule. Okay.
Yeah. Okay.
So it's generally known as probability of B. That's the case. Means what he's trying to explain is that what was the general rule. B given A. And we know that probability of B given A is probability of B given A is probability of B intersection A upon probability of A. Yes or no? And this cancels.
Mhm.
What is left? Probability of A intersection B is equals to probability of B intersection.
Right.
Okay. Yes, that's it. So, and you should know. Okay, that's the thing. And it comes to like that. Okay. So, okay, there is an example here. Come on, read this problem. The Pew Internet and American Life Project reported that 79% of teenagers ages 13 to 17 use social media, and 39% of teens who use social media feel pressure. Okay, so there is a condition here.
Mhm.
Okay. So the Pew Internet and American Life Project reported that 79% of the teenagers use social media. So probability of teenagers, probability of teenagers using social media is 79%, means 0.79 the probability. Okay.
Mhm.
And 39% of the teens and 39% of the teens who use social media, who uses social media. So they use social media. Teens uses social media, who use social media. So there is a condition there. Who use social media feel pressure to post content. Feel pressure feel pressure to post content or likes. So the probability is 0.39. Okay. So we can write probability feel pressure using social media, given that using social media is 0.39. I've rewritten this thing in shorter form. Okay. So guess a lot. Find the probability that the randomly selected teen uses social media and feel pressure. So we need to find FP intersection uh, FP intersection US. So it will be probability of FP into probability of FP given US. So it will be,
Mhm.
what is probability of FP? We have written here. Acha, we can write it in two form. See here. First of all, I need to clear what he has given there. We can take, see here. Probability of A intersection B can be written in two types. Probability of A
Mhm.
into probability B given A, or you can write it as
Mhm.
probability of B into probability of A given B. Okay, anything you can do. So what I'll do now, this is not working. The first one I've used here, but it is not working. Why? Because we don't have these two. So what I'll do, I'll let F intersection U. So it will be probability of U into probability of U given F. U given F.
Mhm.
So I have, okay, now I don't have U given F then. Oh, yes, F given U.
Mhm.
Wait a minute. What we'll do here. So what he has done is, see, uses social media, means he's taken U. Okay, 0.39. And teens who use social media. So we are taking a teens who use social media. So U given, okay. So how he has written probability of use social media dot feel pressure given, okay. So he has taken as fear intersection U. So he has taken probability of fear, na, by the way, use social media. Use social media. So has he given the probability of using social media? Yes, it is. Okay, okay, okay. The first one was correct then. Okay, using social media into probability. You can take F given U also. So it is, what is U, 0.79 into 0.39. So what will be the final answer there? It will be 0.308. So it is around 30,
Mhm.
means intersection uses both is 30.8%. Did you got that?
Mhm.
It was simple by the way. Okay, so the last topic of today and this chapter also, tree diagrams and conditional probability. So Sharon hits the snooze button on her alarm at 60% of school days. If she hits snooze, there is a 0.70 probability that she makes it her first class on time. If she doesn't hit snooze and get up right away, there is a 90% probability that she make it to class on time. Suppose we select a day at random and record whether Shannon hits the snooze button and whether she arrives in class on time. Show a tree diagram of this random process. So how to represent the probability on a tree diagram? So see how he has distributed the things. See here. We'll take it on board. Okay. So what was the question at? First of all, the probability was distributed into two. Where it is? Sharon hits the snooze button on an alarm on 60% of the school days. Mean Sharon hits Shannon hits the snooze button. The snooze button. So what's the probability? 60% of the days. So they have distributed 0.60. Left is 0.40 because the total is 1. You know. Okay, the sum of the so hits button, does not hits button. Does not hits button. Now we'll move it into two. If she hits button, what she'll do, and if he does not hits button, what she'll do. So if he hits the snooze button, so what's the probability that she goes on school on time, late, on time, and late? Okay, if she hits the button, so that's the probability 0.7. 7, okay, and here it will be 0.3 as summation of both are complementary, so that will be 1, and here the probability is 0.90. If she does not hit, so she's on time is 0.9 and it's 0.1. Got that, Zain? How to draw tree diagram? It's very easy.
Yeah.
Yeah, just give me a minute, I'll be back.
Okay.
Okay, so that was how to draw tree diagram. So tree diagram, we'll take the definition. So this is tree diagram. So remember this is what I need to give you a concentration on and why. See here how we have designed this. This is the complementary event. Huh? If this is A, when we are drawing two arrows, so this is A and this is A complement. And the probability always of A plus A complement is 1. So if you have given A and you have told that draw a tree diagram, so you can predict the probability of B also. How I have predicted 0.40? 1 minus probability of hit the button, snooze button. So 1 minus 60 will be 40. Yes or no? 1 minus 0.6.
Yeah.
So this is how I have predicted the probability by this. Here also, for suppose this was given, so how I'll predict this? Late, it will be 1 minus 0.7, 0.3. Same as here, if it is given that she's late, if it does not hit the button, so what will be the probability that she is on time? So I'll 1 minus 0.1, it will be 0.9. From either of the case, if any one is given, you can predict the other. Is it clear?
Yeah.
Yeah, so tree diagram. So a tree diagram shows the sample space of a random process involving multiple stages. So this was the first stage. See, what we are doing generally in tree diagram is that We are distributing the whole probabilitical condition using that diagram. Means how many stages it have and how can we distribute the whole probability into. This was the first stage, this one, and then this was the second stage. Either she is on time or late. This was the both the consideration was the second stage. So we can distribute the whole sum, the whole sample space into different stages. The probability each outcome is shown on the corresponding branch of the tree. All probabilities after the first stage are conditional probability. So all the probabilities after the first stage. This is the first stage. All probabilities after the first stage. After this, what all branches comes, they are all conditional. They are all conditional. Okay, this probability is the original one. This and this. These two are the original probabilities. Or then all are conditional, dependent on some condition. Is it clear?
Yeah.
Yeah, so that's a tree diagram. We'll do a question. Okay. Can you draw a tree diagram, Zed? Come on, do it. I'm waiting here. You draw it and send me on my WhatsApp. Come on, fast.
I could just tell you right now.
Yes, right now. Yes. Let's do it
Like,
and tell me.
guys, because I can't really draw it right now, so I'll just tell you.
Yeah, okay. You are just telling me. Okay. So come on, tell me what will be on the first stage. So first of all, read the whole question first. One time. Give a look at the question one
Huh?
time. Then try. Come on, read it once.
Recently, Harris Interactive and reported that 20% of millennials, 25% of Gen Zers, 21% of baby boomers, and 70% of matures read more ebooks than print books. According to the U.S. Census Bureau, 34% of these 18 over are millennials, 22% are Gen Xers, 30% are baby boomers, and 14% are matures. Suppose we select one US adult at random and record which generation the person is from and whether she or he reads more ebooks or print books.
Okay, so recently Harris Interactive reported that 20% of the millennials, 25% of Gen Zers, 21% of baby boomers, and 17% of matures read more ebooks than print books. So, what is the main general discussion between?
Hmm, I guess it.
Okay.
Hmm. So people who read print books and people
Print
who
books and
read
one partition
ebooks, I
is one
guess.
partition is one partition will be we need to find the whole first partition. So is it the first partition? First, we'll make the first partition
Mm-hmm.
is reading ebooks and print books. Okay, that was is the first means one partition is not the first. You will say the only one. One partition is then the second partition will be uh, uh, baby boomers. According to the Census Bureau, 34% of those 18 over are millennials, 20% are Gen Zers, and 30% are baby boomers, and 14% are mature. Suppose we select one US adult at random and record which generation the person is from and whether she or he reads more ebooks or print books. Okay, so draw a T diagram to this model this random process. Okay, we have to draw this tree diagram for this random process. So random choose an adult. So first we need to randomly choose adult. So randomly choose adult. Okay, so what are the four types of people? They are every time descripting of millennial. I'll write M. Okay, then it's G Gen Zers and baby boomers and matures. Okay, so what is the probability that millennial have two types? Millennial they have 0.25 for we put 20 20 per 0.20 20 read more ebooks than print books. Means 20% read more ebooks. So it will be 0.20 will be millionaires. So what will they read ebooks? So for suppose, see these probabilities, all these probabilities are for read more ebooks. It's for ebooks. Okay. So it is for ebook. So what will the probability for print book? I've told you 1 minus 0.20, so it will be 0.80. Gensers have how much probability? 0.25 for ebooks,
Mm-hmm.
0.25 for ebooks. So what will be the probability for print books? So it will be 0.75. Yes or no? Same
Yeah.
as it for this. So you can complete the tree diagram. Is it clear, Zaid? Yes or no?
Yeah.
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 So this is how the tree diagram is done. So the next question is find the probability that the person read more ebooks than print books. So what we need to find, we'll just look into the example here. See, this was how we have to draw a tree diagram. Yes.
Mm-hmm. Yeah.
Yeah. So the second question was, so read we we need to find probability, find the probability that a person reads more ebooks than print books. So we need to see whether they read more ebooks or the print books. So probability of read more ebooks. So it is you have to give the multiplication and add all that. What they are adding generally, read more ebooks than print books. So in each case, we have
Mm-hmm.
three cases generally.
Mm-hmm.
More ebooks than print books. So what we need to find? R intersection E intersection P. So you can do it on your own also. So the third question was, suppose that the chosen person reads more ebooks than print books, what the probability that he or she is a millennial. So you can go through this reasoning. Okay. So Zaid will have an half an hour class only today, as I have
Mm-hmm.
some work further, college work, and I have to leave for college a bit
Oh,
earlier. Okay. So we'll have an
okay.
half an hour class. So we'll complete this half an hour tomorrow. We'll take a 1.5 hour class tomorrow. Is it clear?
Okay.
What I'll
Yeah,
do, I'll
got
stop
it.
here. We'll complete
Uh-huh.
the other half in tomorrow and complete this chapter. We are just left with a small part of it. Then we'll complete it
Mm-hmm.
tomorrow. Is it clear?
Okay, got it.
Okay, I'll stop the here. So, Assalamu alaikum. I'll share the recording. Okay.
Walaikum salam. Okay, Hafiz.